Hello students, welcome to a second lesson and a simple classification of substances. We are going to look at solid-liquid mixtures. There are two categories of solid-liquid mixtures. One, we have the solids that dissolves in a liquid. They are said to be soluble, while there are solids that do not dissolve in a liquid. Therefore, they are referred as insoluble solids. So we shall look at insoluble solid liquid mixture. Then we are looking also with soluble liquid mixtures. We have to look at solubility of solids in liquid. We're going to use water and propanol as a liquid. Solids can be tested for solubility in water and propanol. So we have sodium chloride as one of the solid, sugar, we have sand, sulfur, oxalic acid crystals, potassium nitrate, iodine, and then we have naphthalene. Pour out 10 centimeters cubed of water into a test tube and add to it half a spatula of the solid. Repeat with the experiment using 10 centimeters cubed of propanol, or sometimes known as acetone. Note, propanol is flammable. That is, it catches fire easily, so you have to be very careful when you're using propanol. Observation: sodium chloride, sugar, potassium nitrate, and oxalic acid crystals dissolve in water. Therefore, these solids are said to be soluble. Naphthalene, sugar, and oxalic acid dissolve in propanol, so they are soluble in propanol. Oxalic acid and sugar dissolve in both water and propanol. Naphthalene, sand, sulfur do not dissolve in water, hence referred as insoluble solids. So we look at insoluble solid liquid mixtures. We have sodium chloride, potassium nitrate, sand, and sulfur did not dissolve in propanol. Sand and sulfur do not dissolve in both water and propanol. Substances that dissolve in liquid are said to be soluble, while substances that do not dissolve are known as insoluble. When a substance dissolves in a liquid, the substance is said or called a solute, and the liquid is said or called a solvent. So, for example, if you're dissolving sodium chloride in water, sodium chloride will be referred as a solute, while the dissolving solvent, that is water, will be referred as a solvent. The resulting mixture is called a solution. When the solution is stirred, it forms a homogeneous mixture. What is a homogeneous mixture? It is a mixture in which the solute and the solvent particles are evenly distributed. Separation of soluble, solid, liquid mixtures. To obtain sodium chloride from a mixture of sodium chloride and water. So in this case, sodium chloride is soluble and water is a liquid which dissolves the sodium chloride. Here we have the solute and this water is a solvent. The solution of sodium chloride is put in an evaporating dish and heated until crystals start forming. So the evaporating dish is then transferred to a water bath and continue heating to dry the crystals. So this is the setup where you have your solution here and then you heat. Discussion: sodium chloride, or what we call the common salt, is soluble in water. The evaporating dish is heated to drive away water into the atmosphere. This process is known as evaporation. Evaporation is a process of changing liquid to gas or vapor form. When crystal starts forming, the evaporation dish basin is transferred to water bath so that the salt does not spit out of the basin as heating continues. So we have this setup to allow and to avoid spitting of salt. The method is used to obtain salt from seawater. Then we have a second experiment to obtain copper 2 sulfate crystals from copper 2 sulfate solution. The concentrated copper 2 sulfate solution is put in an evaporating basin. Using a water bath, heat the solution to evaporate excess water. As heating continues, dip a glass rod into the solution regularly and allow it to cool in air. Why do we do that? We should, when the crystals start forming on the glass rod, remove the evaporating basin from the water bath to allow it to cool down. So we use this one to check whether the solution can start forming the crystals. Discussion. The glass rod is dipped in the solution to find out whether the solution can form crystals on cooling. When they form on the crystal rod, it is an indication that the solution is ready to form crystals. At this point, the solution is said to be saturated. So a saturated solution is one in which no more solutes can dissolve at a given temperature. This process of obtaining crystals from a saturated solution is called as crystallization, because it forms crystals from a saturated solution. The method can be utilized to separate most soluble substances from their solutions. So you first of all dissolve it in water or maybe the solute or the solvent. Application: extraction of sugar from sugarcane, then extraction of medicinal substances from plants, and extraction of salt from salty water, e.g. we have this in Lake Magadi and Ngomeni in Malindi. To obtain a solvent from a solution, so a solvent like water or propanol. So the solution is placed on a boiling tube or a round bottom flask. This allows the distribution of heat, so we don't need this as a wire gauge unless you're using a thermometer that does not measure up to higher temperatures. The apparatus are arranged as shown below. So we have the salt solution, we have the boiling tube or the test tube. Heating is going on. Then you have the delivery tube and the test tube B. We have the cold water. This is colorless liquid. So the solution is heated until all the solvent has evaporated. Discussion: as heating continues, a steam is produced that passes through the delivery tube, this one, where some of it condenses on the cooler parts of the delivery tube and to colorless solution, this one. The colorless liquid formed is the test tube is water. The cold water in the beaker acts as a coolant that facilitates condensation. A white solid remains in test tube A. The white solid is sodium chloride. This method of separating a solute like sodium chloride from a solvent like water is called simple distillation. To improve the condensation process, Liebig condenser is used instead of dry delivery tube, and cold water in a beaker. So we have this setup. We have the stand, the solution is here. Then we have the light bead condenser. This is a light bead condenser with inlet and outlet. Note where the inlet is down here and the outlet up there. So then we have our distillate here, our conical flask, and then water goes in and move out from the outlet of the light bead condenser. So as the steam passes from the round bottom flask to the conical flask, it is cooled down by cold water in the light bead condenser. The counterflow between steam and the cold water in the light bead condenser condenses steam to water faster than in simple distillation. Counterflow, vapors flows in opposite direction to the cooling water. So we have the vapor moving that way, then we have water moving that way. So that is what we call counterflow. The vapor flows in opposite direction to the cooling water. Insoluble solid liquid mixtures, we continue. We have separation of insoluble solid mixtures. Decantation method to obtain sad water from water sad mixture. When you have a mixture of insoluble solid like sad in liquid like water, you are supposed to allow the solid phase to settle down and carefully pour out liquid in another beaker. Done this way. So you allow this one to settle and then you pour out the liquid and you're left with some solid particles. So discussion. SAD is insoluble in water and it is denser than water molecules. Then when a mixture of SAD and water is allowed to stand, the SAD particles settles down at the bottom of the container. Why? They are insoluble and also they are denser than water molecules. When they settle down, the water is then poured out carefully. This method of separation is called decantation. It is not an efficient method of separation because some solid particles pass into the liquid in the process of decantation. That is why this water is not clear. They are suspended solid particles. Water being collected using decantation method is not clear. Filtration method to obtain SAD water from water SAD mixture. To separate soil from a mixture of soil and water, we have apparatus and chemicals, beaker, conical flask, filter paper, filter funnel, soil and water mixture. A filter paper is folded into a cone shape as shown below and placed in the funnel. The mixture is poured carefully on the filter paper and collect liquid in a conical flask. So this is how you make filter paper. You fold it once, then you fold the second time, then you form the cone. This cone is the one that is placed in a funnel. So fine sand particles collect on the filter paper as shown in the diagram on the right side. So we have here the mixture and then we have the filter paper, we have the funnel, then we have the residue, then we have the filtrate in the conical flask. So the solid particle left on the filter paper are called the residue. So they remain here, they can't pass through the pores of the filter paper. Water collected in the conical flask is clear since the filter paper does not allow solid particles to pass through. The liquid that collects in the conical flask is called filtrate and the method is called filtration. So this is the filtration method. Filtration is used on a large scale in water purification plants. Here is assignment for you. There are 7 questions. Ensure you remember everything. Don't refer any secondary material. Ensure everything comes from your brain. Thank you and wish you success.